So, hi and welcome again to everyone who just joined to our webinar today together with Alex and Afaf from ABB. We're going to discuss today about how intelligent cyanide and process control helps to maximize performance, in particular on the gold leaching side in the mining industry. And before we start, I quickly want to introduce everyone to how we work here with questions. So if you have questions, please feel free to ask them all time during the webinar. And you can do that by using the Q&A button in the Zoom application below. And at the end, we'll have a Q&A session where we'll then go through the question that we received, and we hope that we can answer all of them. Before we started, we did a quick poll on where everybody's joining from and what their experience with advanced process control and cyanide optimization is. And so we have a tie today between most people are joining us from Europe and North America, but we have also a few from Asia and Oceania joining us, as well as from South America. And most of you today have at least heard about it, and even some are using advanced process control right now. And most of you are interested in what this technology can offer and can bring to the gold mining industry as a whole. And we're very excited to help you learn more and see what's possible today. With that, I would like to go to the next slide. And introduce today's agenda. So first, I will introduce our guest speaker, Alex, in the next slide. And then Margarita, our mining solutions expert, will walk you quickly through what we do at CyanoGuard, in case you haven't joined one of our early webinars yet. And then she will hand over to Alex, and Alex will show you what ABB has been doing on it.
So I was just saying that I want to introduce Alex to you. So Alex is the Global Technology Manager for ABB's Process Industries Division, and it's based here in Switzerland. He has been trained at ETH Zurich and can look back on decades of experience with optimization and digitization, both from an R&D and operations perspective in various industries. And before I hand over to our guest speaker today, our mining solution expert, Margarita, will quickly summarize what solutions we offer here at CyanoGuard and how this helps gold mines all over the world to optimize their process, particularly the cyanide leaching process. With that, I would like to hand over to Margarita.
Thank you, Benedict. Hello, dear ladies and gentlemen. I will start my presentation with a brief introduction to CyanoGuard Solution, as Benedict already mentioned. Our solution consists of the single-use cartridges with proprietary chemosensor and portable handheld analyzer, which conducts the measurements and transmit results to our online cloud-based platform. Our technology is much more accurate and reliable than any alternative in the market for two main reasons. First of all, it is not based on silver nitrate titration method, and unlike titration, has virtually no interferences. And secondly, it is digital and as such is not prone to human error, has low variability, and provides instant measurement results which can be accessed online from anywhere. CyanoGuard Solution can be a perfect choice for replacing the outdated manual titrations and also for verifying measurements from built-in automated analyzers, since they are eventually also based on titration method and thus have the same limitations. With our technology, customers know exactly how much cyanide they have in their process, which eliminates the need to overdose. This allows to visibly reduce cyanide consumption by 15% on average, improve gold recoveries, and cut detox reagent costs. With CyanoSmart Analyzer, the operator can do measurements at any point in the production process It takes just a couple of minutes. The data, such as measurement result, GPS location, and user tag, are uploaded in real time to Cyano.io platform, where managers can remotely monitor and control cyanide concentrations. CyanoGuard solution is fully digital and can be easily integrated into advanced process control systems at the mine. We support the general trend towards the digital optimization of the processes at mining companies, because digitalization is vital to achieve sustainable operational improvements and ensure long-term competitiveness. Data analytics allows mines to holistically improve operations from the crush all the way to the ADR plant. Value of our solution can also be maximized when integrated with digital process control systems, which provide the infrastructure for advanced data analytics. And at this point, I would like to pass the word to Alex, who will share with you ABB's perspective on the APC system's capabilities when it comes to process optimization.
Yeah, good morning and good afternoon, everybody, and thanks for joining here. So I think we can directly go into the matter, and the question also why running this webinar together with CyanoGuard, and maybe if you can just directly jump to the third slide. Yeah. I mean, it was some time ago that I met Benedict, and he was introducing me to this new measurement technology for cyanide. And actually, I have to say I was very excited because I understood that there is, by getting more measurement of that parameter, getting basically the foundation of I mean, getting this process also optimized. And of course, I mean, measuring and getting the data to some dashboards is one thing. And of course, I mean, we immediately thought about, okay, how could we include that in kind of really in kind of a control loop, and really use then latest methods in process control strategies to really kind of optimize this process. I mean, if you expected us to present a ready-made solution, I have to disappoint you. I will also show you a bit more about that. That's not the way it works. But it's more, I mean, to explore together if there is opportunity to really unlock value in a kind of a collaborative approach. And I mean, collaborative usually means that we need, I mean, companies and also, I mean, measurements like CyanoGuard is offering. We need basically also infrastructure and platform for process control to make it work, and also a lot of, let me say, expertise in how to optimize processes. And of course, what is also always needed is the expertise of the customer in his particular process, because I mean, each mine is different, and the situation is different, the process is different, the materials processed are different. So it needs a kind of a collaborative approach to explore if we can create value in a collaborative approach. Before I go a bit into the details of also advanced process control and also our references and what we were able also to do in the mining area, I would like just to give you a short overview of what ABB is doing. So maybe not familiar to everybody here on the call. I mean, ABB is a pretty large company with 110,000 people working. I mean, a lot of engineers, scientists also. And I mean, the portfolio is really huge. It's really products, it's systems, and it's more and more also, of course, services and software that we deliver. I mean, we are working globally in all geographies, and I mean the customers are mainly utilities, industry, transport, and infrastructure. Of course, I mean today we are talking industries here. On the next slide, you can see a bit more when we dive into ABB. I mean, ABB has certain business areas, and when we go to the business area of industrial automation, basically where I am based, you can see just to get an idea about the size here. I mean, we are talking like $6 billion business per year. And mining is very much in the center of industrial automation for ABB. It's not just it's kind of on purpose that this is also the picture in the middle here. So in industrial automation, we are working with more than 20,000 employees, and we do a lot. I mean, we are #1 really in DCS and process automation in this area. We do a lot in measurement and analytics as well. I mean, cyanide we don't have in our portfolio. That's another good reason to team up here with CyanoGuard. Yeah, I mean, it's a broad offering really. From hardware all the way up to the really latest digital solutions using artificial intelligence methods. So it's basically ABB was growing from delivering hardware to over automation systems, now also in this area of digital. Yes, on the next slide, a bit more about our, let me say, references in mining, just that you get an idea of how we relate to mining. I mean, we have more than 1,000 DCS systems out in the mining. We have like 1,000 hoists. We have grinding mills. We have conveyor belts. I mean, what you don't see here on that picture is the amount of, let me say, software systems that we have installed. But that is a huge number as well. And on the right hand side, and that is also a very important piece also when we talk process optimization, and I will explain you also later a bit why, is that we have these remote collaborative operation centers that basically can help our customers 24/7 on their operations. And so this is of course if they subscribe when they subscribe to this service. So more and more it's also about really providing the needed support and service and not just delivering something and then leaving the site. Yeah, on now I would like to talk a bit about I mean the ingredients that we need for a successful process control and optimization. On the next slide, please. And I mean, what some people claim, I mean, oh, there are so many data that you have anyhow. I mean, you don't have to measure more. Yeah, so you can extract a lot from your data. To basically optimize your operations and your process, and that's kind of true. You can do a lot, but I mean, if it's about really controlling a particular process, I mean, the measurement and accurate and reliable and frequent measurement is a kind of a key ingredient to get to a proper proper process optimization. Furthermore, I mean, it needs also an infrastructure to collect signals and data and process it. It needs modern tools for data analytics, also to gain more process insights. because I mean what human can do. I mean they have their ideas of how things work, but I mean there is another truth in the data that you can basically read out by kind of number crunching tools and algorithms to see also dependencies that you were not aware of without having these data insights. So that is also something that is very much needed. Then of course, I mean, you need the right control algorithms and strategy to apply to your process that you would like to optimize. And it also needs, I mean, really experts in that area. Sometimes even scientists, if the problem gets a bit more complex. And this is basically all you find all of that under the hood of ABB. And then I think typically most important is to really have the people on board that really know the process, that know day to day in and out the problems and the things that occur and the anomalies that happen, and have that kind also of sometimes feeling how what to be changed to get a certain outcome. And that's very important to take that on board as well. And so this is all together needs a collaborative approach between parties. And I would not exclude that in some cases, I mean, you have even more parties to join that cooperation to really make it work together. So let me now talk a bit really about advanced process control. And I mean, typically what you want to achieve, I mean, you want to maybe reduce your energy consumption. You will would like to reduce the use of reagents that might be also expensive, like also with the cyanide. And at the same time, I mean, you want to maximize your production. I mean, you often have also kind of the targets to basically increase your throughput. You would like to reduce production variations, also to stabilize quality. And then it's also a lot about, of course, I mean, the environment, because I mean, when you have a better process that is more optimized to the outcome that you expect, that has in all cases also, let me say, impact on the environment. Okay, I mean, our solution, I mean, we have shown and examples of a wide variety of APC solutions in mining, where we can really show significant benefits that we deliver, and I will show later also a bit an example, and that really turns into dollars that you can count. Of course, also we have a kind of the service behind in these collaborative centers to keep also the solution up and running. So when we go to the next, a bit more particular on what it is and how it works in a bit more, let me say, abstract way. I mean, you could say that it's kind of an autopilot to drive the plant to an optimum stage. It basically automatically changes the set points for the process parameters, and typically what is achieved is that the variations during the process are from batch to batch or from process. I mean, the variations, you can reduce the variations by also making smaller steps in adapting the parameters than rather having a few big ones. also because it runs automatically. And on the right hand side, I mean, you see, I mean, on the lower part of the pyramid, you have your valves, you have your I mean, whatever your process does or needs in terms of actors and sensors. And these things basically you control in a control loop, and for that you usually use SCADA, PLC, or a DCS. And so you close the control loop on the lower and the middle piece of this pyramid. And the changes of the set points typically is done by experienced operators. So you have maybe some variation of the incoming material also, and then people adjust that to their knowledge and understanding of what has to be adjusted, that this control loop works. And what the APC does, I mean, that APC is using algorithms that, for example, this model predictive control, basically these are algorithms that can somehow predict on what the future process stage will be. So there is some kind of prediction, and then they control it towards that prediction, what will happen. And there are other also advanced methods that can be applied depending on the process and the problems that you have. And this layer then is basically changing the set points automatically in the underlying control loop. So that's how it works. You can already see on that picture that it's very important that you trust this APC and those algorithms, because the changes of the set points that might sometimes also be a bit counterintuitive, and is not the same that sometimes operators would do. So it's for that reason also it's very important to develop those solutions together with the people that are on the process, that they understand how it works. It's a bit also like this topic, what is called explainable AI. I mean, it's still, I mean, the responsibility is still is with human people. That are responsible for the outcome of that particular process with their KPIs. So it's important that it's also understood how it works, and have the people basically also be involved, because typically also when we implement this project, it's at the same time also it's a kind of a change management process that goes with that. So we have not only to deliver infrastructure and technology and pieces of software. We really have to, I mean, make also the people that are working with the process aware, and take them with us in this change. So this is about let me say the more overall let me say structure. And then on the next slide, I would like to show a bit on an example, technically also what happens with this let me say control strategies and what they can do. I mean, typically when you have a process that you have some limitations to the process, some kind of boundaries that you should not go above or underneath. Yeah. And when you have this bigger project fluctuations that you see, process fluctuations that you see on the left side, you cannot basically bring your set point lower in this case, because you would leave in some cases you would leave the let me say the limitations that you have for your process parameters. And the first step, basically what you do with this control strategies, is to bring those fluctuations down, basically make it more precise following the optimal stage, the process. And by that, having the fluctuations reduced, you can, within your process window, you can basically put the set point to an area where it basically makes you more money. And that's basically what we try to do. I mean, we try to put something in place that improves the financial KPIs. Yeah. Maybe then on the next slide, that is a bit more a practical example. If we can just jump to the next slide. Unfortunately, the order here is not optimal. So this is about how we were able to increase ore recovery at a given concentrate quality. And it's about, I mean, an APC solution that is applied to a grinding circuit. And so what we did in this solution, I mean, it's not only a model for that we have on how the process works. It's really also the cost functions are behind. So we want to understand, I mean, what energy cost, for example, at which speed of the mill, etc. And so the target is that you can drive the process towards a certain also financial KPI targets with your control system that you install. So basically in this example, I mean, all the optimal set points, they are chosen automatically. And then you can, on the right hand side, basically you can see what the improvements are. It's throughput. It was a reduction of the specific energy, basically the energy per ton material that has been grinded down. And then it has also some impact and some advantage then for the next process step, because it also helps then to extract more from the material. So it's not only optimizing then the first step, but also the subsequent one. And that's, I mean, typical that the process steps, they have some interdependencies. And that's also what we are looking into, that we can I mean, basically also optimize over several steps in the process chain. When we go to the next, or it was the one before in this case, yes. Here you see really that is what we really like to see when we basically are finished with our first step of the work. So we would really like to see we switch it on, yeah, and then you have a certain improvement that you can really that is significant. And in this case, it was throughput, it was particle size that went down, specific energy went down a lot, yeah. And then in the subsequent step in the recovery, you had also some increase. Because of course you have to make sure also that what you optimize in this process step is also not harming then the next step, so that you lose basically again what you was gaining beforehand. So that's a very neat example to show that we can really deliver value, and there are many of those examples that we did. But as I said, I mean, it's always a work with the customer together, and some other stakeholders if needed to really achieve that. So there are no ready-made solutions for that kind of optimization problems. When we go to the next, yeah, it was that one, yes. That is basically giving another example where we have developed an APC for a customer in Sweden where we could increase recovery by 1%. And I mean, you can imagine that this is huge numbers in terms of money. I mean, 1% doesn't sound so much, but the question is it's 1% of how much? Yeah? And this is huge. Usually, I mean, in this industry, and that's also why I really like that working in that industry. I mean, you can achieve huge benefits and create huge values by those kind of methods of optimization. When we go to the next, I would like to tell a bit also about the evolution of APC in general. And I mean, the concepts, they are known since the 80s, and they are I mean, have been really productized solution developed for kind of mainstream processes like in cement, where you can basically more or less buy a piece of software that you buy when you get your automation system. And you apply that because your process is so I mean uniform compared also to your competitors and also to the ones that you have in maybe in other plants of your company. So that was kind of the starting point. The problem is that I mean you basically commission that advanced process control by basically tuning your algorithms and tuning the parameters there. And then, I mean, you deliver that basically as a piece of software, and then you leave. And also we as ABB, we left. And then after, if you come back after a year or so, and you ask, I mean, how is that working? I mean, basically you get often the message, we switch it off. Because it didn't work anymore, or didn't really bring the results anymore. So the switching off can have different reasons. I mean, one is this acceptance reason that I was telling before, that I mean, operators somehow don't trust what this autopilot is doing. But I mean, very often it basically happens what you see on the top here of this circle. You get some changes in the overall, let me say, conditions. Maybe ore is coming from a different place. Okay, a bit let me say different conditions, or you get some also changes in your equipment, or a temperature sensor is not giving the exact temperature anymore because there is some fouling on the sensor or whatsoever. I mean, there are changes to the process, and then the whole thing doesn't work anymore. So your accuracy of the system drops. And I mean, what we are doing here in the meantime, I mean, we basically look to with some analytical tools to much more data around, and apply also some machine learning here to basically warn and show that the APC is not working anymore correctly. And this is then, I mean, either customer can fix it on their own, or this is where we come in also with our collaborative operation centers, where we then can basically look at it, and our experts can evaluate what happens and bring it back. Yeah. And I mean, in the future, I think there will be even technology that does then this adaptation of the control parameters automatically by basically detecting the change of the accuracy of the control. But that is very important to understand, that this data analytics approach and this classical APC approach, that the classical APC approach still works with a physical understanding of what happens in the process or chemical understanding. And the data approach is basically does not take that into account. That just looks at the data and signals and see some probabilities that if you have a lot of this, then most probably that happens. Yeah. So these are complementing approaches that also when you go for let me say advanced process optimization that are used also together to basically in this case to keep it up and running, but also to develop the right control strategy. It's important often to run some analytics on data beforehand to get more insight into the process. Okay, then I mean I was talking before a bit also. I mean it requires also infrastructure. I mean one thing is to have clever algorithms, but you need infrastructure to also run those algorithms somewhere, and you need platform to collect the signals and the data and so on. And that's why I just wanted to show you quickly also our kind of portfolio in an overview. A picture where I highlight basically in red here where we have the let me say the infrastructure pieces that are needed to make finally a solution work. And I mean what we have to mention here, of course, we have this expert optimizer that is kind of the product name for our APC offering. We have of course the automation system. I mean you can, for example, use a kind of an 800XA DCS environment from ABB to run your APC on. I mean including even the hardware that comes with that platform. But there is when I then also think about CyanoGuard's product and how to bring the data back from the cloud to the control, that is also a bit of a challenge. And here, I mean, typically the platform used would be this Genius that has also the capabilities to take data from IoT devices. And also there is, for example, a feature that is called mobile operator, so you can also connect mobile devices to the system to get the data into your premise. All that works. I mean, this Genius, as the name says, that is something that works on premise. I mean, the data do not have to leave the premise or the site. They do not have to go to the cloud, because also we learned that customers not necessarily like that. I mean, there are cybersecurity topics behind, and of course also data ownership topics, etc. So in case that is a kind of an obstacle, we can also build solutions where we pull in the data from devices like this CyanoGuard device directly into the system to work with the data. And then I have highlighted also another kind of a platform product suite that we launched recently. And that is about, I mean, making all kind of analytics with the data that you basically collected via your Genius. Yeah. And I mean, there are many methods that are proven, I mean, to work very well in the industrial applications. And I mean, they are designed in a way that you don't need a data scientist every time to work with this data, so that you can create process insights basically with a I mean medium level of knowledge. But we also use that, of course, I mean, when we work together with customers to find I mean values to be created in processes here. So that's about a bit our portfolio here and how that works together. And given the time, I skipped the next 2 slides. That was a bit more about the genius, but you can read that all on our webpage if you have more interest in what the features are there and so on. But I would like to go directly to the takeaway messages that I would like to give you once more. I mean, we know by experience, I mean, in these mining processes, there is a huge potential. I mean, there's a huge potential for optimization when you apply also modern technologies, APC, data analytics, and the combination of that. And I really like to encourage everybody to I mean, basically look into that because I mean we have the experience and it's really huge money that you I mean kind of waste by not applying those methods. Yes, I mean the things they need infrastructure, so there you need software and even hardware to make it work. There is for those kind of things also our webinar invitation title might give a bit this impression. There are no ready-made solutions, but there are companies like ABB and I mean we know that we can make it work. Yeah? So but a really ready-made solution would not then be working for the next customer case. Yeah? All those solutions, they are worked out in a collaborative manner where basically all the stakeholders are included. And I mean, we even as ABB, we even have a methodology for that collaborative value creation, and we can also take the lead here to run that procedure or that process. I mean, this is something where we have also kind of standardized workshops on how to work together to focus really on how can we create value. So it's no longer about kind of here is our APC product, we would like to sell it to you. I mean, at the end, the discussion starts with what can we achieve in terms of value by applying those methods, and that needs a in deep I mean conversation and certain steps in a workshop. So with that, I would like to close here, and thank you very much for your interest and listening to me here. I mean, I asked basically 2 questions. One question is, do you have questions? I would hope so. And the second one, are you ready for the journey? Because this is not something that you just buy and it's done. I mean, it's usually it's a journey because you start somewhere, and while you do it, you realize, oh, I have even more potential here and there. So it's often a beginning of a journey for really improving mining operations. Thank you very much.
Thank you very much, Alex. So given the time, I think we focus on just 1 or 2 questions, and let me quickly check what we've got. So yeah, I think a first question for you, Alex, something that you already mentioned during your slides is what are the most critical steps and factors to successfully implement those APC solutions?
Yeah, I mean, I would say one success factor is, of course, this. Let me say the expertise of process optimization in general that you have to bring in, and I mean also the domain expertise that goes with that. So, and you need a combination of a very deep domain expertise of how those processes really work, and that can be, I mean, sometimes we have that, yeah, because we did something very similar or the same before. But I mean, often that goes in a combination with the expertise of the customer, or maybe another party that we have to pull in to if you realize that you might not understand it good enough, really what happens in that kind of black box or silo or whatsoever. Yeah, so it's really that combination of the more theoretical know-how about how to optimize control and processes, and the other piece is really the domain expertise that we need.
Thank you very much. So we have one more question, and that's I'm just going to read it to you. Since data is the fuel for analytics in cases of lack of historical data, how have you modeled an APC using modern algorithms?
Yeah, I mean that's a very good question. I mean, often the problem is that there is not enough historic data. So then, I mean, in case you cannot do it really data driven or data fueled, I mean, then you rely even more on a kind of a physical understanding of what happens in the process as such, and really be able to understand what is cause and effect of the different. So it's then going a little bit more in trying to get the digital twin for the process as such. But I mean, having let me say tons of historical data is typically let me say helps a lot to achieve let me say the faster. And that's why, I mean, what I've shown also on this infrastructure part, I mean, also collecting the data, that's maybe also an important precursor for further optimizations of the process, and can also be something that can just be started, you know, that you basically have that data that you need later in also in a structured way. And I'm aware that not everywhere you have that basically big repository of data already.
Thank you very much, Alex. I think this is actually a very good question, because this is something that we've seen, especially on the optimization of cyanide. Cyanide leaching, that often the data there is not available, and this is one of the reasons that we're really focused on sort of generating high quality data first, because with all the different cyanide readings you have, maybe for manual titration, maybe through automated analyzes or external laboratories, you can hardly use this data to model or to create an optimization approach. And this is really where we want to come in and try to first gather high quality standardized data to then be able to work with partners like ABB to then model an APC and achieve a process optimization. Yeah, with that, we're already a bit over time today. And I would like to thank everyone for joining, also for the great questions. Sorry if we could not answer all the questions, but in case we've missed one, we'll get back individually to you in an email. Thanks again. Thank you again, Alex, for joining and for your great presentation. We'll try to share some resources and content afterwards, like we did in the past webinars. And with that, I wish you a great rest of the morning or afternoon or evening, wherever you might be, and hope to see you in our next webinar.
Yes, stay safe. Thanks.
Thanks a lot.
Thank you, guys. Bye.
Bye.